The focus of this lesson is to talk about what it means to be an exponential function. So we're going to look at two functions here, f of x equals 2 to the x and f of x equals 3 to the x. And what I want you to notice about both is they both have a base. So in the first the base is 2, and the second the base is 3, and they're raised to a variable power. When you raise to a variable power, that's when we're talking about exponential functions. So it has to be a variable, and so it varies. So in this case, the power is your independent variable. It's your x-axis, and your dependent variable is your base raised to that power. So your height is your base raised to the power. So the idea behind what it means to be an exponential function is that as your x increases by, let's say, 1, then your f of x is going to increase by the base as a factor. So for example, the base here is 2. So as your x increases by 1, then your f of x is going to ultimately double. So think of it, if you start out at 1/8 and you double that, you're now at 1/4. Times another 2, you're at 1/2. Times 2 again, you're at 1. Times 2, you're at 2. Times another 2, you're at 4. Double it again, you're at 8. And on this would go as x increases by 1. And so you can kind of see as x increases by 1, your f of x continues to double, and that's what it means for it to be exponential growth. And we could graph that. So if x is -3, we're at 1/8, which is a small number close to 0. If x is at -2, so if we're 1 bigger, then your f of x is a little bit bigger. It's at 1/4. If x is -1, we're at 1/2. If x is 0, we're at 1. And if x is 1, we're at 2. If x is 2, we're at 4. If x is 3, we're now at 8. So you can see as we go along, as x gets bigger and bigger, we continue to double, so the growth is more significant as we go rightward. And that's what it means to be exponential growth. And in the same respect, if we had the example f of x is 3 to the x, as x increases by 1, our f of x triples each time. So we go from 1/27 to 1/9 to 1/3 to 1. Triple that, you get to 3. Triple that, you get to 9. Triple that, you get to 27. And so again, if you go to graph that, when x is -3, your y is 1/27. So that's something really small, close to 0. When x is -2, you're at 1/9. When x is -1, you're at 1/3. When x is 0, you're at 1. When x is 1, you're at 3. When x is 2, you're at 9. And you can see that the growth is even more significant than the last example. When x is 3, you're at like 27, which is somewhere way up here. And it's an even steeper exponential growth, if you will. And that's because the base is larger. Your base is 3 this time, so you're tripling each time. And that continues on that way. So that's what it means to be exponential, and that should demonstrate what it means to be exponential growth. So as you increase rightward, your growth is even more and more significant as you go along.